So we are live now at the Star Open House. We're looking at the SX38. We're actually going to focus specifically on this machine now for the next few minutes. It has been attracting a lot of attention. This machine was launched at EMO a few weeks ago in Hanover. It's come over the water. It's first showing here, and it has been one of the highlights this week at the event. Now the SX38, 38mm bar machine, but you can go up to 42mm bar. But the big point about this machine is its flexibility. The fact it has a bottom turret on it, it has a B-axis, and all of these axes can be used on front or back spindle. They can be used in conjunction with each other to balance turn. It really is some machine, isn't it?
It is, Paul. I mean, it's making its UK debut, like you say, at the Star Open House. And for me, you know, you mentioned the B-axis. It's a fully programmable B-axis with 8 spindles on the B-axis, which really illustrates the machine's capabilities. But then you move on to the main and the second spindle. The main and second spindle have got equal power, equal torque, 11 kilowatts on both. So when you're planning your work, you haven't got to think, I've got to do this part on the main spindle and then the second up on the second spindle. It doesn't matter. So you can plan it in the most efficient way that suits your part. The power is a big aspect. You mentioned the bottom turret as well, Paul. The size of the turret, you can see for yourself, it's a chunky turret with even more milling capability on there. This is a machine that is to cut not just soft materials as the demo part, but very hard materials as well, you know, with a weight of 5 ton.
I think that's what Gio's putting across here is correct. This sort of part has got so many features on it: engraving, flats, holes, slots. I mean, the whole lot. Irregular machining. And the idea behind this sort of part is that normally you'd look at a part like that and you would go, right, how am I going to machine this with the axes I've got, with the tools I've got? Now you look at the part and you think, right, you know, to get that down to the minimal cycle time, I'm going to do it like this. In fact, I'm going to use the back spindle, I'm going to use the front spindle, I use the B-axis on the front or the B-axis on the back. You know, you can actually optimize incredibly powerful machine to get these off as fast as possible.
I mean, for me, Paul, you look at a part like this, it's got milling and turning in, and most people would associate sliding head machines with predominantly just turning, you know, let's be honest, mainly just turning, but the game has changed, if you like. It's a different ballpark now that we're playing in with Star. With these machines now, you could make prismatic parts complete. You can bar feed round bar and make prismatic parts out of hard material. You know, you've got that torque, you've got that capability. I mean, your possibilities are pretty endless and limitless.
And I think that the balance turning for me is a big part as well. It's having 2 tools coming into a component and machining them in a simultaneous fashion to remove double the amount of material, which means you're getting the part off of the machine in twice or less than half the cycle time. That's the thing about this SX. It is a 38mm bar machine, but you can go up to 42mm. And this is another point I would make. Years and years ago, I used to sell sliding head lathes, you know, 32mm machines. You might get to 36. I remember selling a machine and someone saying, wow, 36mm bar, but now we're going beyond that. We're up to 42mm bar capacity.
We spoke to some people this morning that are using Star that previously used fixed head lathes, and it has transformed their business.
Well, let's go and have a look at that, actually. Let's just go to... I'm going to pick this out because this is something, this SV20, another highly capable machine with a turret on it. You've got, again, a vast array of tools, working tools on the back or driven tools on the back spindle and the front spindle. But this sort of part, when you were selling, Gio, you're selling your work holding, you would have gone into a job shop and he'd have said to you, I need a vise, I need a couple of vices, however many vices, to hold 100 of those on my VMC. So I'm going to machine op 1, then I'm going to turn it over and machine op 2, and that's what you would have, that's what you would have been selling, isn't it? But now it's made on here.
It's a really good analogy. I think that you've hit the nail on the head. People need to start thinking out of the box. Can you just imagine the amount of work that would have went into a part like that? You've got 2 operations on that part. You would need 2 operations, but you know, they're not an expensive part. You need to be producing them extremely quickly to make any money on them. So how do you do that, Paul?
And it's the handling of it as well, isn't it?
You're doing it in one relationship. You're keeping the tolerances from one up to the other tied up exactly perfectly. You haven't got no mismatch or no discrepancies between op 1 and op 2.
And the flexibility is the one thing to do this. But also, to me, the introduction of more powerful spindles, heavier machines, bigger constructions means that, okay, this is an aluminium part, but if it was an Inconel, if it was a titanium, it wouldn't matter.
It wouldn't matter at all.
You would still you'd still get the part off to an extremely tight tolerance. You would still experience less tool wear as a result of the machine stability. So the savings, and to me, it's all about changing your thinking.
You know that part there, Paul? I worked in the aerospace industry, and through my own experience, for some of the engine parts, for the Trent 1000, whatever, very small, intricate parts, that you made, they're repeated every month. They weren't extremely high volumes, but most of the time they were out of the same material, similar features. You could be bar feeding them out of one bar and running lots of different family of parts. Imagine that. Imagine introducing that capability into your factory. What would that do to your business?
I think there are so many machine shops you could go in now, and you could literally take out, vertical machining centres, 5-axis machines maybe even, and put these machines on the deck, make the parts faster, make them overnight unmanned with all the automation that goes with these, and essentially make them for less money.
Absolutely. I think all of the other machines will definitely 100% still have their place. However, but for certain applications, I think that what we're saying is think out of the box. Don't kind of think that it's just for turn parts and making very high volume parts. That could be a thing of the past. Everyone's looking for flexibility.
I think what we'll try and do over the course of the coming hours, we're here all day today, is we'll try and get an interview with someone that has actually, changed the way they're thinking, and actually gone from doing them on a milling or doing parts on a milling machine across to this type of technology. We'll try and do that, so we'll keep you posted. That's it from us for now here at Stars Open House.